warm up 1.1. First time we do these. You'll see these at the beginning of the lessons. As you come in, feel free to do these as quick as you want, because we will always discuss them. And so this right here is just to see, do you know how to handle positives and negatives? This is something my own children talk about all the time. You can type that directly into your calculator, can't you? You can. Does anybody just type 12 times 28? You can, because will this be a positive answer or a negative answer? Yeah, if that's what it was, but this is a negative, so it's a positive times a negative, we'll get a negative answer wrong. So what is it? Negative how much? 336, very good. And I'm not going to do my calculator up here right now. You can. All right, we have negative plus a negative. Do we add these two negatives together and make it more negative, or do they subtract from one another? And so this is where we get to try things, and it's all right to make mistakes. If you do type it in your calculator, it does it for you. But yes, that's negative 23 added to a negative 15 makes a negative, was it 38? So you can write a rule right here. Adding same sign. The rule I always follow, if I'm adding the same sign, so in this case it's two negatives, add and keep the sign. That would be a good thing to write in your own book. Math is very exploratory. While doing math, you learn things. No one has to know all this stuff already. I hope you don't know all of it already, or you wouldn't be learning anything. So we're learning when we add the same sign, we add and keep the sign. That is something that you've probably practiced somewhere. And practice it again. How many people will just type that into your calculator and let the calculator do the work by show of hands? And that's fine too. It's up to you. These tools of algebra, the practicing these things are meant to make life easier later on. When we don't want these kind of things to even be something to slow you down. We'll just go right back. All right, right here. This one, put it into your calculator. You probably get a negative answer. What do we get? Negative 2. 2 1/3, or negative 7/3. Depends on the test you're looking at. So today, no. And this calculator will do that too. Yeah. We'll look at that. Over here, ordering the numbers from least to greatest. I like to take each one of them and make that fraction into a what? What do you think we should make it? Yeah, if we make it a decimal, it makes it a lot easier. So 1/2 is 0.5. 1/3 is 0.3 repeating. 2/5, anybody help me there? 0.4. Remember, with your fifths, you can double your numerator, and that'll be your decimal. It's 2/5, the same thing as 4/10, or 0.4. And then 3/16 is how much? How many people know on your calculator? Just type it in. If you don't know the decimal, you type it in your calculator. Here, we'll demonstrate. So I'm going to use my calculator, and I'm going to say 3 divided by 16 is 3/16. That's funny. So if I don't want it 3/16 to appear 3/16, I hold down Control and hit Enter. and it switched it over to the decimal. Well, if I hold down Control and hit Enter again, it went, stayed at the decimal. If I just hit Enter, it goes back to fraction. Control Enter. So you can see, you can just keep hitting Enter depending upon whether you're hitting Control or not, sends it one way or the other. All right, so anyways, 0.1875. So if you're ordering from least to greatest, which fraction is the smallest? 3/16, 0.1875. Yep. Then the 1/3, everybody agree? Then the 2/5, then the 1/2. That is our least to greatest. Then this one right here is in decimal form already. Does anybody notice anything interesting if we were going to put this in least to greatest? They're all zeros. Okay, they're 0, so they're all less than 1. Point. We compare decimals left to right. These two have a 0, these two have a 3. So would you agree the second two are larger than the first two? And then when you compare the first two, go to the next decimal. So looky here. Those things are already in order from least to greatest. So if you kept them in that order, good job. Everybody happy with that? All right, so we got our brains warmed up a little bit. That was a warm-up. All right, now turn the page. When you turn the page, you see the subsets of real numbers. This is what we discussed yesterday, how real numbers, not talking about imaginary, but real numbers can be broken down into different categories. And this describes them at the top. One thing I really want you to notice is this one right here. Put a star besides 0.3 repeating. 1/3 turns into 0.3 repeating. 0.3 repeating has a pattern. It repeats 3, 3, 3, 3. That is rational or irrational? Rational. So this decimal doesn't end, but because it repeats, it's still rational. Irrational are all the ones that do not repeat and do not end. So that describes them. That's one good thing to catch. We talked about that before. I like this diagram here because it breaks it down like, hey, irrational people, you're over here in this room. You're one category. Then rational is in this room. If we take all the what off, we become integers. We take off the... How do we get from just rational numbers to integers? We take off the decimals. Very good. We take all the decimals off, the parts. We take the negatives off. We get into the whole number category, and if we take off 0, we get into natural numbers. There's your counting numbers. All right, so that's everybody's favorite number category. We're not going to talk about that anymore. Turn the page. All right. Some of my favorite properties of real numbers are these top two. These top two, when it comes to tools of algebra, are some of the best tools to make your life easier. So you can fly through certain parts, make certain parts of math easy. I wonder how opposite or additive inverse of any number, a is negative a, how the fact that their sum is always 0 will make your life easier. Here's what I want you to do. We're gonna put into practice some additive inverse. So right here, at the next page, you have something to write on. You have a place to write. So at the top of that page, write additive inverse. We're going to practice some additive inverse. This says, right here, here's some examples. If I took -5 and added 5, it equals what? 0. That's nice to know. That means if I have a tool, I don't have to think. Hey, opposites, these are opposites, right? And the additive inverse property says when you add opposites, they cancel each other. It's 0. Okay? Check it out. Here's another one. I have negative 2.5. Oh my goodness, I have fractions. I have 2.5. It's all right. If I'm adding them, it's just 0. Make your life easier. Here's a crazy one. Pi added to negative pi. It's sad when all the pi goes away. You guys, remember, there are 2 types of pie I like if you ever want to bring me some. Hot and cold. Okay? Here's something that's more applicable for Algebra 2. You're going to deal with stuff like this. 4xy squareds added to negative 4xy squareds. Now, it doesn't matter that they're xy squareds. That's the kind of term it is. When you have 4 of them here and negative 4 of them here, they still equal 0. That's opposites of one another. Happy with that? Okay. Turn back. So reiterate. Additive inverse says adding opposites equals 0. The next really cool one is the reciprocal or multiplicative inverse of any non-zero number. A is 1 over A. And the product of the reciprocals is 1. Now here's the key. Look at these 2 numbers. They're not the same, are they? But if I'm adding 2 things together, what can I add to anything and it not change the sum? 0. I can add 0 to anything and it won't change the sum. So 0 is a nice number to play with. Now let's look at this one. What can I multiply to anything and it not change the product? 1. 1 is very friendly when it comes to multiplying. All right, so let's practice that. Let's practice that. I know that looks like chicken scratch. That says multiplicated inverse. If I can multiply something times its inverse, it should equal 1. That tells me negative 4 times negative 1/4. I don't have to worry about doing the math. If I recognize, oh, those are reciprocals or inverses to one another, I know the answer. If I recognize those are inverses or reciprocals, I know it'll be 1. They simplify to 1, right? That's that word simplify. Here's another one. Have you ever tried 2/3 times 3/2? It's just 1. Because that is inverses or reciprocals. Or you could even do this. That says 4x over y times y over 4x. That's something you might see in Algebra 2, some term that looks like that. And you go, oh, wait a minute, 4x over y times y over 4x, that's inverse. That'll just equal 1. I promise you guys, somewhere this year I'll be like, hey, guys, that's the inverse property right there. Don't stress over that math. That's just equal to 1. While we're right here, something else that we're going to talk about today is what absolute value means. Now this was from Students' Mouse. I had students this morning say absolute values on the number line. Raise your hand if you've learned absolute value already. How many of you guys? A little bit? I had another student that says it's the distance from 0. Sorry, my writing is horrible. And I had another student say it's always positive. I agree with pretty much everything right here. It is distance on a number line, and it's always positive. Have you guys ever heard of a negative distance? Well, if I traveled from here to Tuttle, I traveled a distance. That value's got to be positive. I go from here to Rush Springs. I can't say I went a negative distance because I went south, can I? No, that's not true. Any direction you go, that distance will be positive. Okay. I'm going to give you some examples of that in just a minute. First, flip back. Flip back to the other side. These are the properties of real numbers. When have you heard about these? Ever since 5th grade. From 5th grade on, you learn about the commutative property, the associative property, identity property, inverse, distributive. The closure property, you might not remember as much. Hey, the ones that get confused with each other are the commutative and the associative because they both deal with order. Who knows the difference between commutative and associative? Very good. Yeah, associative parentheses. Commutative just says, hey, you could do 5 plus 1, that is 6. That's the same thing as 1 plus 5, right? Flip the order. In a multiplication, what's 7 times 2? Anybody?
14.
7 times 2 is 14. What's 2 times 7?
14.
So it doesn't matter the order with adding and multiplying. So associative also deals with order, but like you said, it also involves parentheses. Here's how I remember it. Everybody put your hands up like this. So when my daughter goes through the lunch line, she comes through the lunch line, she goes into the cafeteria, the biggest dilemma of her day is she going to do this one? Is she going to associate with those people? Or is she going to associate with those people? One more time. Is she going to associate with them or with them? All right, so your parentheses, you can put them down now. Very good. Your parentheses were your arms moving back and forth. That came from an old Chris Farley movie when he was like acting crazy like this on Tommy Boy. You guys, you can move your arms back and forth. You can imagine, am I going to associate with you or with you? And that might help you remember that associative property is the one that deals with parentheses. You'll have an opportunity today to practice these. See if you can recognize these different properties. You've done this for a while, right, guys? I think you've seen these. Okay. Now, I'm going to show you a couple examples here of absolute value. How would I simplify this right here? Negative 7, 6. What does that equal? What is the absolute value? Those bars are your absolute value bars. What's the absolute value of negative 7, 6? 7, 6. 7, 6 value, or distance from 0, is 7, 6. That's all there is. Or how about this? Sometimes the absolute value bars act like parentheses where you have to simplify the inside. What if I say 12 minus 16? The absolute value of 12 minus 16. What is 12 minus 16? Negative 4. So I'm going to say negative 4 is the inside. So I simplified it down. So now I can say, what's the absolute value of negative 4? 4. Okay. Or you might have sometimes an expression that has absolute value here minus the absolute value here. So I want to rewrite this without those absolute value bars. What's the absolute value of 3? Minus, what's the absolute value of negative 2? 2. So it's the absolute value of 3 minus the absolute value of negative 2, which is really just 3 minus 2, which is 1. I'll go with that. Can there be a negative when absolute value? Can I see a negative answer when absolute values are involved? Yes, I can. If I go like this, where's my negative sign? Outside. So the absolute value of 4.2 is 4.2, but there is a negative sign there. And this is what we call, what kind of numbers in math? Anybody know what we can call that? What is right there? An understood what? There's an understood 1. And we call those the invisible numbers of math. Some people do. There's understood numbers in math. Sometimes they don't write them, but they're there. So this one is still negative 4.2. Okay. Well, I'm going to try to stop recording. Maybe. Maybe. Yeah. There it is.